This is an introduction on Fourier series, so I'm going to be covering the basics of it and what you need to know, and we're going to solve a problem. Now, I'm not going to try to prove the formulas or kind of go on and on about where it came from and why, whatever. I'm just going to give you what you need to know in order to pass your classes, in order to pass your, in order to solve the problems in the FE exam and whatnot, and just the essentials. That's what I'm going to give you. So I'm not going to go over how to derive the formulas. I'm assuming that you already know that, or your professors already went over it. So what's Fourier series basically? So it's because a lot of students, they get confused with it because it's one of those abstract concept in engineering, in electrical engineering, or even math. I mean, I think Fourier is part of math as well, but it's one of those subjects that people get confused a lot because we don't know how to apply it. So essentially, Fourier series is just a method, just understanding as a method of representing any periodic function as a sum of sines and cosines. That's it. That's all you need to know. So it's just a way of representing a function by adding cosines and sines. So you need to be able to know how to do integration by parts. You need to recall or remember your trig functions, and also understand even and odd functions. So if you know these three things, you should be good to go. You should be able to solve any Fourier series question. So essentially, this is the main formula. And again, I'm not going to try to prove it at all. It will take long time to do it, and it's not necessary. So this is like a Fourier series formula, and these are your coefficients: a0, an, and bn. So big picture, all you need is just try to find a0, an, and bn, b sub n. That's it. Plug it in the formula, and that's your Fourier series. So we have an example problem here. Let f of x be a function of period 2 pi. So we have f of x 1 and 0. 1 is between, the function is equal to 1 between minus pi and 0. And the function is 0 between 0 and pi. So the question is to find the Fourier series. Now, all we need again is to find the coefficients of this big formula, plug it in, manipulate it, kind of do some simplifying, and then find the Fourier series. So a sub 0 is equal to 2 over your period. Now there are different notations of the formula. There are different variations of it, but it depends on what your basis is and what your period is and whatnot. But essentially, this is the general formula. You may find different variations. Some people use L, and then they define L, 2L as 2 pi or whatnot. But so you have to be able to apply the formula that you're given. So in your classes and whatnot, depending on what your professor's using, which variation of the formula they're using, just apply that one and understand the different notation and the different variation. But essentially, the concept is all the same. So let's go ahead and find a sub 0. That's 2 over the period. So our period here is 2 pi. It's already given. So 2 over 2 pi, that's 1 over pi. Alright. Now we are integrating. So the function here is a piecewise function. So you have f of x is equal to 0, is equal to 1 between minus pi and 0. So we're going to have to integrate between minus pi and 0, and then between 0 and pi. So these are your limits. So minus pi to 0. Here they're using f of x, same difference. So I'm going to use f of x d of x plus between 0 and pi f of x d of x, right? So a sub 0, from here on it's just a matter of integration, right? So 1 over pi. So again, I guess I'll have to put the brackets here because the 1 over pi applies to the entire function. So we have 1 over pi between minus pi and 0, f of x is equal to 1, so I have 1. I'm integrating between minus pi, 0, 1 dx plus between 0 and pi the function is 0, so I don't even have to write it, but let's just go ahead and do that. And again, the 1 pi applies to the entire function because you're integrating between minus pi and you have a piecewise function, 0 to pi, but between 0 and pi your function is equal to 0, so you can write 0. So this will cancel, and now you have a sub 0 is going to be 1 over pi integrating minus pi well, let's just start solving it from here. There's no need to repeat it. And I apologize for if I'm taking too long. Sometimes I just rather show all the steps. I think it's better that way. So this video may be longer than necessary, but I just rather detail all the steps. So if you integrate d of x, it'll just give you x, and you're doing that between minus pi 0. So this is equal to 1 over pi zero minus pi, which will be pi. So pi over pi is equal to 1. So we can come over here and put that our a0, our a sub 0, let's write it here because I'm running out of space, is equal to 1. Alright, now let's go ahead and find the next coefficient, a sub n. So let me let's erase all of this. I'm running out of space. I should have I forgot to check out the settings so that I can scroll down. I'll try to find that next video. Alright, so let's find a sub n. I'm not sure why I can't erase that part. A sub n. Alright, so a sub n is 2 over the period, so it'll be 1 over pi. And we are integrating the same thing. The function will be different because now we're multiplying not only the function with, just like over here what we did, f of x, we'll multiply that by cosine of n, and then the function x. Alright, so again, I'm going to use between minus pi and 0, f of x cosine of n and x dx plus 1 over pi from 0 to pi f of x cosine of nx dx. And again, from here on, it's just a matter of integration. A sub n is 1 over pi minus pi to 0. F of x between minus pi to 0 is 1. So we can just say it's cosine of n of x dx. Here, f of x between 0 to pi is equal to 0, so that whole thing goes away. I don't even have to write it. So now, a sub n, integration by part, not by part, but regular integration. So you have 1 over pi. So this would be 1 over n, right? The entire derivative of cosine of nx would be 1 over n, right? Sine of nx. So you can always check it out in order to make sure that you get it right. Is if you take the derivative of this, the n will come out, they cancel out, and you will be left with cosine n of x. So that's how you check if you get it right or wrong. So this will be integrated between minus pi and 0. So we can take out 1 over n pi. Sine nx, so it'll be sine 0. Right here, you replace x by 0, and then 0x by minus pi. So minus, there's already a minus. If you replace x by minus pi, it'll be minus n pi. So a sub n would be sine of 0 is equal to 0. So I'll put n sine of 0 is equal to 0, and sine of minus n pi is also equal to 0. This is your trig function, and remember I told you earlier that you need to know your trig functions. So this whole thing is equal to 0. So a sub n is equal to 0. Now we have a sub n is equal to 0. Now next would be to find b sub n. But during the exam, if you're taking the FE exam and they give you like a question to find, let me erase this as I'm talking, and they give you a question to find Fourier series, you don't have time to do all of this because you only have like how long, like 3 minutes, 5 minutes to solve a particular problem. And that's where knowing your odd function and your even function comes into play, because if f of x is even, for instance, your bn is equal to 0. But if your f of x is an odd function, a sub n is 0. And I will do an example on that as well. But recognizing your even and odd function actually helps a lot, because if you know this function right here is an odd, f of x in this case is an odd function. But since I haven't covered that yet, I'm not going to get into, I'll just show you how to do it in details first before we look into the shortcuts, because there's a lot of shortcuts that you can use directly in order to solve your problems. But if you have an exam and you're not taking the FE, for instance, and you just have a like regular class, signals class or whatever, your professor probably wants you to show your work. So that's why it's important to know how to do it. But there are different shortcuts that you can use in order to quickly recognize and solve the problem. So next would be b of n. I'm not sure why this doesn't want to erase, but Let's now find b sub n. So same thing, this will be 1 over pi, going from minus pi, same thing, but instead of cosine in this case it will be sine, so minus pi to 0. F of x would be 1, sine of nx. So let me just write it instead of thinking out loud. So f of x sine nx dx. I almost don't have to put the other one, but let's just write it down. This will be, what was it again, 0 to pi f of x sine nx dx. And again, b sub n is equal to 1 over pi. F of x is 1, so we're only integrating between minus pi 0 of sine n x dx, because the rest of it is 0, between 0 to pi. So this would be integration, regular integration, antiderivative of sine of n of x, 1 pi 1 n. So this would be minus cosine of nx between minus pi, I feel like I'm running out of space, 0. Alright, so this would be 1 over n pi. Well, let's take the minus sign out so that it won't bother us. Because if you take the entire derivative of this, it will be n over n, and then you take the derivative of cosine, it's minus, so the minus cancels out, so you're left with sine n of x. So we got it correctly, right? So it will be that, and we have cosine of 0 minus cosine of minus n pi. Alright, so b sub n is equal to minus 1 over n pi. From here is just a matter of math, regular integration. Cosine of 0 is 1, I believe. So cosine of 0 is 1. Cosine of minus n pi, that's the same thing as minus 1 to the power n. So remember your trig functions. So you got to remember your trig function. This is equal to minus cosine of n pi, which is equal to minus 1 to the power n. So this, at this point you can stop. I mean, I don't see anywhere any more simplification that you can do. However, in this case you have two answers. It depends, right? If n here is even or is odd. Let's say n is equal to 1. 1 is an odd number, right? So bn is equal to, if n is odd, bn is equal to, if n is 1, so you have minus 1 to the power 1, which is minus 1. So you have 1 plus 1, which is 2. So you have minus 2 over 2 pi, over n 2 pi, minus 2 over n pi. But if n is even, your answer will be different, because Bn, if n is even, let's say if n is 2, you have minus 1 squared, it's 1. 1 minus 1 is 0. So 0 multiplied by this, it would be 0. So you have to, at this point, you have to take into consideration if n is odd or even. So this is Bn, right? So let's write it down here. So Bn is equal to minus 2 over n pi if n is odd, and 0 if n is even. Now let's erase this, and I apologize for not setting it up so I can scroll down. Having to erase is not fun, but I need space. So I'm hoping that you're following. So all it is just finding your coefficients, and I'm going to do different examples as well so you can kind of see. Sometimes they give you the function itself and then ask you to derive. There are different ways of asking the question, but essentially this is the basic really of Fourier series, nothing else complicated. But professors, some professors, of course, I mean there are good ones, but some of them they can go on and on and on about where you come from, who is Fourier, and sometimes we really don't care. Sometimes I just want to know how to do it and how to apply it practically, and be done with it. Can't erase this part. Alright, so now, man, this is bothering me. Hold on. Ugh. Oh man, this is very annoying. Ignore that, I'm sorry. Oh my, I made it even worse. Oh Lord, hold on. I don't know why it's not erasing. Yeah, just ignore that. So f of t is now, we have seriously, it's bothering me. But okay, whatever. So f of x is now equal to a sub 0. We already had a sub 0, which was 1, so let's put it together. Let's put the whole formula together now. So a sub 0 was 1, so now the formula is 1/2 plus an was equal to 0. So we're not worried about that part, right? The only thing we have to worry about is b sub n. Because a sub n was a function, the coefficient was equal to 0, so anything multiplied by 0 is 0. So now we have to be able to rewrite this in terms of a series, right, of function going from 1, because we got to do odd, going from odd to all the way to n, whatever n is. So because this is a sum of n going from 1 to infinity, and that's the reason why it's called a series, because you keep adding and adding different periodic function, different sines and cosines. So let's come over here actually. So if n is equal to 1, so let me, how do I put this very clean? Let me put a table here. Let's say n here. So 1, I'm not worried about even, right? So I'm not gonna write it down. So 1, let's say 1, 3, 5, 7. Your b sub n, if n is 1, your b sub n is minus 2 over pi. If n is 3, minus 2 over pi, minus 1 over 3, right? I mean, multiply by 1 over 3. Ooh, I'm running out of space. I'm writing it this way so you can see the pattern, right? If n is 5, it'll be minus 2 over pi, still the same, 1 over 5, etc., etc. So if it's 7, it's going to be minus 2 over pi 1 over 7. So that's your b sub n. Now we're multiplying that by sine of whatever. So let's say so we can take, they all have minus 2 over pi in common. So all we're doing right now from here on is writing it as a, cleaner, basically, now that we find the coefficients. So we have minus 2 over pi. Let me erase the plus sign. Minus 2 over pi, right? So this is the sum of minus 2 over pi. So if n is equal to 1, it'll be minus 2 over pi 1 times sine sine of x, right? Here they're using t, but we have f of x here, so this is going to be sine of x, right? Plus, again, this is the sum of n going from 1 to infinity. But if n is even, is equal to 0, so we skip that. So now we have, if n is equal to 3, we have minus 2 pi, which we already have this taken out, minus 2 over pi, 1/3. So we can have 1/3 sine of nx. N is 3, so 3x. And you can see the pattern here, right? So if n is 5, almost don't even have to think about it. It's going to be 1/5 sine 5x, right? Etc., 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 all the way to infinity, whatever, as long as the n is odd. 1 over 7 sine 7x, 1 over 13 sine 13x, whatever. So that's pretty much it. So this is your Fourier series of this particular function. Now this is just a way to show you how to get it out, making sure that you know your coefficients, your trig functions, recognizing odd and even function. I haven't done an example. Well, I could have used odd function to quickly recognize that the function is f of x is odd, and therefore a sub n is 0. I could quickly do that, but I just want to show you how to quickly do it, so that you understand how to apply this during your midterms, finals, FE exam, and whatever. So understand your integration by parts, even odd function, and trig functions, and that's it. I mean, it's not complicated at all. It's just tedious because it's susceptible to different errors, minus sign over here, cosine, sine, but it's really not that bad. So combining it, and this is your Fourier series. So now that you understand the basics, the essentials, this is one example. So stay tuned for another example of Fourier series.